Emerson Speyer. Apologies if I pronounced your last name wrong, but on the topic of understanding the impact process by exploring a newly formed impact crater.
All right, thank you very much. If we can just move on to the next slide. So, studying impact craters has been something we've been doing for quite a while. We've had a select few go and explore impact craters on the moon, which you can see in the upper left. We've also had thousands of geology students go and study craters like Meteor Crater here in Arizona. And then the US government has also created some craters that we've been able to study, like the Sedan crater. In addition to that, we've done modeling. Some of that has been numerical modeling, like we see in the lower left with an ISAIL model. And another example is in the lower right, where we actually look at how impact craters form by doing impact experiments. And so that is an example of an impact experiment in the lower right. So if we can go to the next slide. So with LRO, we've been able to discover a whole abundance of newly formed impact craters that have formed in the last decade. And an example is a 70-meter crater over to the right. And with the LROC cameras, we've been able to reveal different reflectance zones around the crater, up to 4 that typically form. With Diviner, looking at these new impact sites, they've been able to identify new cold spot features. With LAMP, they've been able to see distinctive reflectance responses, and with MiniRF, they've been seeing increased scattering around these craters. So we're learning a whole bunch just from these newly formed impact craters, but now it's time to actually go and explore one of these features close up. So if we can go to the next slide. So the science objective for a CLPS mission would basically be to go and examine the stratigraphy of the impact site. And you can see the myriad of reference documents or references to community documents that tie back to these individual objectives here. And then so really understanding what the stratigraphy is, because that's important to understand how the crater forms in different areas on the moon under different material properties and under different conditions. Next is to resolve the physical properties and composition of the proximal and distal reflectance zones that we see with LROC. So basically determining determining and understanding how these craters are formed. So we have some good examples of some simple craters here. And then also determine the nature of splotches. So we see these distal secondary impacts around the site, and so really understanding what those are. Are there actually small craters there? Are these dispersed secondaries? What are these? What's really going on? And as a bonus, we can also look at one of the Lunar Exploration Roadmap Feed Forward objectives, which was to learn how to operate in different geologic settings on the moon. And studying an impact crater like this, the idea is that you start far from the impact site and you work your way toward it. And as you progress closer and closer to the impact site, it's going to get a little bit harder to traverse because there's going to be some rocks and things like that to go around. So if we can go to the next slide. So one benefit of looking at new impact craters is there's over 500 so far to choose from. I selected 4 here that I think would be good candidate sites. One is the 70-meter crater I showed on the previous slide. We also have a 35-meter crater. There's also 2 impact flashes that we observed, one on September 11th and one on March 17th. And the benefit of those is we do have a great photometric library of observations taken after those impacts occurred. And so those are, we understand those sites pretty well. And on the right-hand side is supposed to be an AMA GIF, so you can
Emerson, you have 1 minute
around the site. But you basically start off landing near some splotches and then work your way toward the crater and go in and out of the reflectance zones. So if we can go to the next slide. So the required capabilities: precise landing near some of these splotches. You do need some sort of rover capability to actually move several kilometers. This would be to visit several splotches, as well as traverse across different zones. And then camera capabilities need a couple different wavelengths and a robotic arm to provide some perspective. So if we can go next slide, and I'll go real quick. So this is kind of what a crater looks like under different lighting conditions. And so with a robotic arm and a camera, we'd be able to characterize that. And then last slide, real quick. This kind of provides you a perspective of what you would be visiting. So if you were visiting a 30 or 70 meter impact crater, you can kind of see what it would kind of look like. So this gives us a chance to explore a new crater that was just formed basically yesterday. So, and provide insight into how the impact process really works. Yeah, thank you.